Alright, so this is part 2 of the tangent lines of circles lesson. In part 1 we cover exactly what is a tangent line and also finding the side length of a right triangle if given a tangent line. In part 2 we're covering if we have two tangent lines on a circle, two segments on a circle rather, and also if a polygon is circumscribed or drawn around a circle. So let's go ahead and get started. And the first property we're going to look at states that if two segments from the same external point are tangent to a circle, then they are congruent. So B would be our external point here, and we have the two segments A and B, so they're from that same external point, and they are tangent to this circle because we have these right angles here. So we know they're tangent. So that would mean that these two segments are congruent. AB is congruent to CB. Or we can draw some congruence marks here. So let's take a look at this first example. We want to find x, and so we're given that this is a tangent line here, and the line AB and AC are from the same external point of B, so that would make these two congruent. So in order to find x, we just simply set these expressions equal to each other. 5x plus 23 is equal to 8x minus 19, subtracting 5x, so just using algebra skills here. 8x minus 5x is 3x, adding 19, and we get 42. Yeah, 42. And bring down our 3x, divide by 3. 42 divided by 3 is 14, so x is equal to 14. So it's just a matter of knowing the properties, and then you know how to set up your expressions here. So let's try another one. I would like for you to try example 2 here. You have to go a little further and actually find a measure of one of these segments. But after you find x, of course, you know to just plug it back in. So go ahead and pause the video and try this problem on your own. Alright, so you should have gotten that PQ is 29. Hopefully you got it correct. You will get x equals 3 and just plug it back in. And of course you could have plugged it in actually right here as well with QR because they are congruent. So 8 times 3 is 24. And 24 plus 5 does give you 29. So you could actually plug it into either one because they are congruent. Alright, so let's move on to the next problem. If you don't see how I got the answer, you may want to just pause the video here and analyze my work a little bit more here. Alright, so this problem is a little different. We have to find SV, which is this segment right here. And I'm actually going to call it C, and you'll see why in a minute. So we have to find this segment here, SV. But before we do that, we need to find x, and then we have to use x to find this segment here. But let's go ahead and find x. Since these segments are tangent, of course, we know we could just set them equal to each other. So 10x minus 41 is equal to 4x plus 7. And just solving for x here, using more algebra skills, a lot of algebra and geometry. Subtracting 4x, I'm adding 41 to both sides. 6x is equal to 48, and then we divide by 6. So x is equal to 8, but we haven't found our answer here. We found x, and we want to find SV, so we're given ST and SU. So let's plug it in. So if we found that x is 8, so 4 times 8 plus 7. 4 times 8 is 32 plus 7 is 39. Plug it in here. 10 times 8 is 80 minus 41. So we found that these segments are 39, all right? But we still have not found SV. Well, what do we know about tangent segments? Well, if you remember from part 1, they are perpendicular to the radius. So the point of tangency here is U and T. So that will make these right angles, right? because these are tangent lines. What do you think about when you think about right angles and right triangles? What formula could we use to find a side length of a triangle if it is a right triangle? If you're thinking the Pythagorean theorem, you are correct. We use Pythagorean theorem a lot. So remember, the Pythagorean theorem is a squared plus b squared is equal to c squared. A and b are your legs, and c is the hypotenuse. Remember, the hypotenuse is always opposite the right angle. So in this case, SV, which is here, is opposite the right angle, right? It's opposite both right angles. So it would be the hypotenuse of either one of those triangles, because we're going to get the same thing because the sides are the same. And ST and TV are legs, or SU and UV are legs, right? Because they are not the hypotenuse. And so our legs are 17, right? That's one leg here, and 39. Okay, and again, we know that this is the hypotenuse because it is opposite the right angle. So just plugging it into this formula here, 17 squared plus 39 squared, and you know that this is interchangeable, right? You could do 39 squared plus 17 squared, it doesn't matter, you are going to get the same answer. So now I don't have my calculator ready like I should have. So 17 squared is 289, and 39 squared is 1,521. Adding those together, and we get 1810. 1,810 is equal to c squared, and of course we just take the square root to get the c by itself. So 1810, the square root of that is 42.5. So C, which is really SV, is 42.5, and so we have found SV, which is 42.5. And of course I could have used any variable, doesn't matter, as long as you know that we have to use the Pythagorean theorem. Remember, you can always use it if you have a right triangle and you're given two sides and you want to find that third side there. All right, so let's move on to the next set of problems here. All right, so the last property we're going to learn here states that if a polygon is circumscribed around a circle, then all sides are tangent. And remember, circumscribed simply means to draw around a figure, touching it at points but not cutting it. So we could say here that triangle ABC is circumscribed about the circle P. And so if all of these sides are tangent, that would make D, E, and F points of tangency, right? And if they are tangent, that would make the lines perpendicular to the radii. So that would make this a right angle, this a right angle. This would also be a right angle. And using our knowledge of the property we just learned, so for example, if we choose the point DE and DB and BE, they're from the same point, B, right? So that would make these sides congruent. So DB and EB are congruent. So I'm going to say DB and BE, yeah. And also AD and AF are congruent. And then also EC and FC. All right. And so we know this property now, so now we can use the knowledge of this property to work out some problems. So let's try some. All right, so for example 5, I'm going to do this one with you, and I want to have you try example 6 on your own. We want to find the perimeter of the triangle below, so let's go ahead and label these sides here. So we got this point of tangency here, or label our radii. And so it's easy, I do this because it's easy for me to figure out which sides are congruent. So these two would be congruent, DG and DH, HE and EI, congruent, and GF and IF would be congruent as well. And so DH would be 11, EI would be 16, and GF would be 9.5. So these are what I've written down using the property we just learned. And then, of course, I just want to add the size. So I'm going to do 11 times 2 plus 16, and this looks like an 11, but these are congruence marks. 16 times 2 plus 9.5 times 2. And if I solve all of that together, that's 22 plus 32, right? And that's 19. Adding all of that together, I get 73. So the perimeter of the triangle DEF is 73, and I would like for you to try number 6 on your own. So go ahead and pause the video and try number 6 on your own, just finding the perimeter of this quadrilateral. Alright, so you should have gotten 180 for the perimeter of this quadrilateral. If you did not, go ahead and pause the video and analyze my work here just a little more. So we reached the end of our lesson. I want to thank you for learning with me. Some related videos are tangent lines part 1 and arc lengths in a circle. If you haven't already, please like, comment, share, and subscribe. And once again, I want to thank you for learning with me.